Ever wondered why your coffee cools down or how refrigerators keep food fresh? That's thermodynamics in action. It's the study of heat, energy, and how they move. Everything in the universe follows thermodynamic laws, from stars burning in space to your car's engine running. Understanding these principles helps us design better machines, predict weather patterns, and even explore space. Let's dive into the basics of this fascinating science. The first law of thermodynamics is all about energy conservation. It states that energy cannot be created or destroyed, only transferred or transformed. When you eat food, your body converts chemical energy into movement and heat. When fuel burns in an engine, it turns into mechanical energy. This law governs everything from metabolism to power plants, ensuring energy is always accounted for in some form. The second law of thermodynamics introduces entropy, the measure of disorder in a system. Heat naturally flows from hot to cold, never the other way around. That's why ice melts in a warm room, but never refreezes on its own. This law explains why machines lose efficiency over time, and why perpetual motion is impossible. Entropy always increases, making energy dispersal a fundamental rule of nature. The third law of thermodynamics states that as temperature approaches absolute zero, entropy approaches a minimum. Absolute zero is the coldest possible temperature, where molecular motion nearly stops. Scientists use this principle to create superconductors and study quantum mechanics. While we can't reach absolute zero, getting close allows for incredible technological advancements, like ultra-cold quantum computers and frictionless materials. Heat engines, like car engines and power plants, rely on thermodynamics to function. They convert heat into useful work, but always lose some energy as waste heat. That's why engines get hot. The efficiency of these systems depends on temperature differences. The greater the difference, the more work can be extracted. This principle is why steam turbines power electricity grids and why jet engines propel airplanes. Refrigerators and air conditioners work by reversing heat flow. Using a cycle of compression and expansion, they absorb heat from inside and release it outside. This process follows the principles of thermodynamics, requiring energy input to move heat against its natural direction. That's why your fridge has a motor and why air conditioners consume electricity. Without thermodynamics, cooling technology wouldn't exist. Thermodynamics isn't just about machines, it explains the universe itself. Stars shine by converting nuclear energy into heat and light. Black holes obey thermodynamic laws, radiating energy over time. Even the fate of the universe is tied to entropy, as energy spreads out and structures break down. From the smallest atoms to the vast cosmos, thermodynamics governs everything. It's the science behind how energy shapes reality.